Today I'm going to talk about an open source data pipeline for analytics and observability. It's a combination of a real-time platform like Kafka with an analytics database called Apache Druid. So basically the idea here is to create immediate intelligence. Essentially what that means is you're building a data pipeline. So you can look at various use cases. We can explore the architecture of Druid. And I'll explain how it's a very fast database. So it's basically designed just for analytics. Then we'll talk about Kafka itself, integration with a platform, and how to also use it for observability use cases. Quick show of hands, has anyone here heard of Apache Druid before? Oh, okay, okay. Half the room knows Druid. I like this. All right, so for the other half of the people that have not used Druid before in this room, Druid was basically built to design a real-time analytics platform. It's designed for low latency, querying, and it breaks up data into chunks of time. So every query you do is on time. So big picture, broadly speaking, I view Druid as a combination of Cassandra and Prometheus. So it's a time series plus a columnar database. We'll get into that in a minute. So Apache Druid was started over 10 years ago by the founders, Vadim, Gian, and FJ, and Eric. They started it at a company called MetaMarkets. It's an open source project that they started as to do analytics on ad tech data. So fast forward today, there's over 10,000 plus community members, 400 plus active contributors, and over 450 code releases in the last decade. And now over 1,000 companies are using Druid, from digital native firms to Fortune 100 companies. I'll just name a few off the top of my head. We have Target, that's one big company you've probably heard of, Charter Communications, Cox Telecommunications. A lot of major banks and financial institutions use it for like fraud analytics and so on. So it's used by a lot of companies, and it's designed for just one thing, hyperscale. So it's a fast, scalable database. It's designed to look at real-time ingestion of streaming data. This is queryable just a few seconds later. So from a Kafka producer application to a dashboard, 50 milliseconds. 50 milliseconds. So you're basically able to query data essentially instantly. And the real use case is on combining real-time and historical data. So if you have data in S3 or Hadoop or a data lake somewhere, and you also want to cross-tabulate it with a Kafka stream, like a click stream, you have the facility in Druid to do so. So basically, the idea behind Druid was to just create an analytics database. It's not ACID compliant. It doesn't do transactions. It's just for querying. That's it. So what are some of the use cases that this is all about? Well, if you look at things like risk fraud, so when it comes to exploring risk and fraud, you need to look at a lot of fast-moving transactions. You know, credit card payments, you need to do a lot of queries very quickly, and you need to look at many different things like a customer profile, something that falls outside of their normal purchasing profile. Maybe, you know, they live in the middle of the Midwest. All of a sudden, they bought a coffee 1 minute, and then 2 seconds later, they bought something in Sri Lanka, like a boat and a house. Obviously, that's a risky, fraudulent transaction, and you need an engine that allows you to query all this data very quickly so you can lock down these cards. Next, you have data-driven applications, so websites and apps. If you've ever looked at like Unity before or Twilio, they have like an analytics page that they service their customers. So basically what they do, a lot of data-driven applications, they need a layer that lets their customers slice and dice and explore information. So basically a UI not for procuring orders, but just powering a dashboard, like a Grafana, a Superset, you know, a Tableau, a Looker, a Power BI. All of these things can be made exponentially faster with Apache Druid as a core technology. Another use case is networking, right? So I think a good example of this would be like, you know, Cisco. You've heard of the company Thousand Eyes. It's a subsidiary of Cisco, so they use Druid for network observability. Splunk had Eric Tschetter. He was one of the founders of Druid as well, and he was actually creating the Splunk observability platform built on Druid. You can also look at, Charter Communications, Cox, major cable companies. They use Druid for querying their whole network platform, so they can determine, within milliseconds, 50 or so milliseconds, whether or not there's an anomaly in the network, like a spike in traffic, a drop in traffic, etc. So that's kind of the use case around network observability. You need to look at a lot of data within less than a second, trigger some kind of alarm because a service provider has SLAs, right? They need to adhere to. Click streams. This is a lot of fun, right? So I did an evaluation with a major dating company, and they basically would do what are called experiments. So they would present a new experience to customers, and we would get in all this customer data. I'm talking 5 terabytes a day of data. And they wanted to basically slice and dice this information to understand how a particular user would experience this experiment. And each experiment was like 50 features. So we're ingesting like 50 features, 4 terabytes a day, and they want to query this data in less than a second in like this dashboard. So that's kind of what a clickstream analysis is. You basically take a user profile and you link it with a clickstream. So that could be like what are they clicking on a website? What are they doing on a mobile app? And you need to correlate it and make sense of both the real-time data, the Kafka stream, and the historical data, the user profile information as well. So when you need to join a lot of data, slice and dice it in less than a second, this is a use case that we really focus on. And finally, digital advertising. Like I said, Druid actually came out of Meta Markets. One of our competitors is called Real Data, and they're another entity out there that works on Druid. And basically, the founders of Druid left Meta Markets to start Imply, an open source company, and we're backed by some very good VC firms. A lot of large companies like backing Druid itself, and we'll get into that a little bit later. So what is Druid? So essentially, Druid is a microservice architecture. It's horizontally scalable in 3 dimensions. And what I mean by 3-dimension is you can horizontally scale the querying layer, right? If you need to service more queries for the users, more concurrency, cache some queries, you can add more brokers. Now, if you need to store more data or ingest more data, then you can add more data servers. So these data servers, basically they do ingestion of streaming data and batch data. And then finally, there's a deep storage layer as well. So part of what we'll cover in later on the reliability of Druid is all of the data that you ingest into the local nodes are backed up into the cloud on an S3 bucket, on a Hadoop data lake, on a GCS, on an Azure Blob Store. Pretty much anything you can think of, Druid will back up that data to there. And then finally, there are some master servers, which are actually a combination of coordinator nodes, which handle like which segment to serve for which machine, and it's also Apache Zookeeper. So you have all these different dimensions of scalability available to you as Druid, and that's why the ability of Druid to scale is essentially infinite. You can have n number of users, store n amount of data, and return data results in less than a second because most of the data is stored in memory on cache and SSDs. So what makes Druid so fast? So Druid has 4 strategies that make a really big difference. Data in each period in Druid's timeline uses a columnar format to compress the data. Second, it constructs indexes on those time-sharded columns to enable fast filtering of data. Second, it constructs indexes on these. So basically, what sets Druid apart from the query engines that run on data lakes. And third is all of the operations happen on compressed data as a priority. And finally, it does the work of constructing the final result very late in the process. So first it compresses, takes secondary indexes, operates only on compressed data, and then materializes the results to the user. So you're not reading every single row, reading a fraction of a fraction of a fraction of your columns. But the promise of this whole platform is extreme speed. So this is the layout of a Druid segment. A typical Druid segment is going to have a few million rows in it. This segment over here has 8 because that's how many we can fit on the slide. Now this segment has 5 columns, so in Druid we store data oriented by column. The first column here is time. As you can see, it's a certain integer. The second column is actually called artist. So you have the first one over there, artist. The artist column is a string, and there's 3 components to it. Yep, and then there's a third column called cities for ticket sales. So we have time, artist, and city, price, and count. So you can look across the screen horizontally. So the artist column is a string. There's 3 components to it. The data component, there's only 1 entry there per row, and that's just an integer. So these are the first 3 that are zeros. The second 2 are 1s, and the next 2 are 22. So what this is saying is this is a dictionary encoded string of values. So the first 3 rows, meaning 0, 0, means that the first 3 rows of this particular data set have artist AC/DC, and in every of the first 3 rows, and then the next 2, we have both Kylie and AC/DC. Then after Kylie, there's Silver Chair, which we won't really cover in this presentation. So we do this. This is a form of compression. So it makes the data section smaller, especially when the number of unique values is low relative to the number of rows in the segment, which is common for a lot of columns. It's not universal, but it's common enough that this is quite helpful. But it doesn't just perform compression. It also enables us to operate on compressed data. So you'll see in a bit, what we do is when you're doing a group by artist or a group by city, what we're going to do is actually use the numeric keys to do the grouping rather than the strings, because we can process numbers faster than strings. The next section is dictionary. The dictionary tells us what each dictionary code means, and the third is the index, and the index helps us filter. So what the index is saying is that there's going to be a single entry in the index for every entry in the dictionary, and they're corresponding 1-to-1. And it's a list of rows that contain the dictionary value. So the first section of indexes, which have rows, have AC, DC, and so on. These are also stored and compressed, and they're stored compressed using an algorithm called roaring bitmaps, and they also operate on them in a compressed format. So if you want to do a compression, we're actually going to combine 2 compressed roaring bitmaps together into another roaring bitmap. And finally, the last 2 columns, we can skip city. So the last 2 columns on the far right of the screen are columns and price, which are both numeric columns, just like the timestamp column, and they're stored the same way. So let's do an example query. So here's a simple query, and we want to look at all the ticket sales for AC/DC, and we want to break it down by city, group by city, and then we're going to get the total price in every city. So a query like this is actually quite typical of the kind of query you're going to do with a system like Druid. You're going to do it with some kind of filtering, some kind of grouping, and then break it down into an aggregation. And these are the kind of queries that are going to power these analytic experiences we're trying to power, and we want to be very flexible in the kinds of queries we can do. So we want to be able to support any kind of grouping and aggregations. And because of that, we're not going to want to pre-cache anything. We just want to focus on computing whatever gives us the resources as quickly as possible. So the first thing we're going to do is resolve the filter. And we're going to go to the dictionary. And we're going to see what the code is for AC/DC. The dictionary is stored in sorted order. So we don't actually have to read the entire dictionary. We just do a binary search through it to find the correct value. And we see that AC/DC is the 0 value. The next thing we're going to do is retrieve the index for that value. So that's going to be the first row in the index section. And because it's the first row in the dictionary section, now we're going to get a compressed bitmap that represents 0, 1, and 2. So the first 3 bits being set represent the first 3 rows containing that value. So now we know which rows contain this value, and this is actually super important. This is one of the ways that we start to differ from what is a standard query engine on a data lake. A lot of them don't do secondary indexes because the way you need to use a secondary index involves a lot of random access, and that requires data to actually being stored on the server. And we'll discuss this more in a bit. But with Druid, it's actually prefetching all this data before the querying actually happens. So it has the data stored locally, typically in memory or SSDs. And because it's a mix of SSDs and memory, we're able to use these indexes. So that's why we're only reading the indexes first. The next thing we're going to do is an aggregation. So we're basically going to group by city and select the price. And the way we're going to do it is now we go to the data section of the city column, and we can now see that we're going to the dictionary, the index, and there's no need. We know that we need to go to the first three dictionary values are. It's 2, 1, and 2. And the first two prices are 1800, 2912, and 1933. So we're going to build a little array, and we're going to use that array to aggregate these things. And the reason we're going to do an array is because there's not that many cities. There's only 3. And so we're going to do this is build a 3-element array, and then anything we see for one of the cities will go in the element of that array. So there are a lot of cities, more than we could allocate an array for, and we would use a hash table. So we choose a hash table array based on how many things we anticipate grouping. Anyway, with that being said, we've chosen an array because there's not that many cities, and we're going to group these 3 elements, and there could be other cities as well. So Melbourne has a null value stored in it, and that's the end of that. We don't have to read the rest of the data in the section of the city column because we know from the index of artists that there can only be 3 rows that contain anything that we care about. We don't need to read the dictionary yet because we don't actually care what city values are there yet. We're just aggregating. And now we're actually going to read the dictionary. We've done the aggregation. Now we've read the dictionary to see what the actual values are. And we do this after aggregating because typically when we're doing a group by, a lot of times the output of the group by, the number of grouped rows, is much smaller than the number of rows we're reading. And so it pays to defer this dictionary lookup until far later in the querying process. So this is the idea of operating on compressed data as much as possible. Now look what we've done. As we've read, we've done a binary search through the dictionary section of one of the columns. We haven't looked at the entire dictionary. We've only looked at pieces of it. And we've done a single random access to the index section of the columns that we've done. We just read the sections of the city and the price columns that we need based on the index of the artist column. We haven't read past the first 3 rows because we didn't need anything to. We've read only 2 values out of the dictionary using random access for the city column. And what we've done is very economical about how much data we read from disk, from memory, how much we've had to transfer to the CPU, and this is where we get our performance from. We get the performance from being extraordinarily economical about how much data to read and process. And then once we process each segment in the economical way, from every segment we have a partial result. And then we just have to merge all the results together, and this is how everything works in a Druid cluster. We can query billions upon billions of rows in less than a second. Remember, it's fractions of a fraction of a fraction of a second. That's the key differentiator of Druid. So going back to where we were before, you kind of know what the segment structure is and how to compute efficiently on query processing. Let's look at the distributed architecture, right? Processes have many segments in parallel. Faster response times equals to more scale. So indexers produce segments in real time when they're consuming from a screen. And while building the segments, you can also read from the indexers as the real-time data is coming in, and we'll process this in a second. So historicals are indexed segments distributed across multiple machines. This allows parallel processing of the data. And you also have a second copy of the segment that's stored on a different node for resiliency. So a data node could be deleted, but you can fully recover from anything else. And thirdly, your segments are replicated a 3rd time to the cloud for a backup, which is your HDFS, your Azure, your data lake. So there's high availability for multiple production use cases. And together, indexers and historicals respond to queries on both real-time and historical data, all in parallel, all infinitely scalable, and infinitely resilient. So now let's talk about my favorite topic in the world, which is Apache Kafka, real-time data. How many of you have used Kafka, heard of Kafka? Show of hands. Okay, everyone here has used Kafka. Great. So Kafka scales horizontally, just like Druid. And that's mainly because Kafka has just one type of server. It's called a broker, which will broadcast topics to consumption. Each topic is distributed as partitions across various brokers to handle the horizontal scale of the consumption of those topics, right? So partitioning is the way Kafka scales the servicing of its data across a cluster. And just like with a Kafka consumer application, you can have one indexer running for each Kafka partition. Now, it's also interesting to note that you can replicate indexing jobs for streaming. So if a streaming ingestion service fails, it can fail over to another indexing service. And generally speaking, you only need one indexer to service 12 Kafka partitions. But depending upon the size, volume, and the kind of maybe modifications you might be doing, maybe you're doing some fancy ETL jobs in the ingestion, maybe you need more than one indexer for 12 partitions. You could have up to 12. It really depends on the size and variety and velocity of your data that you're dealing with. The point is, you can be as parallel as much as you want. And that's the same thing with the querying side. So because you're actually querying the Kafka consumers in real time, you can distribute those querying jobs across the indexer services. So it's going to hit the ingestion jobs, and then you can query the data before it is written to the historical node. But the real magic of Druid is the data is stored as a database. So you can query data beyond, like, the 7-day retention period. In a lot of the demos and use cases I cover, we have Kafka data that's been stored for like months or weeks, maybe years. And that's kind of the power of using Druid with something like Kafka, is it gives you real-time insights into your data, and you can kind of explore it. This is kind of something interesting to note, but every 15 minutes, Kafka can run a compaction job. Druid can run a compaction job. This is configurable, so you can compact the data that's coming in from Kafka automatically, say every 5 minutes, every 1 hour, every 1 day. And this can be a scheduled job to really compress that data as it comes in. So what does a analytics pipeline look like? Well, I'll kind of tell you. There's a couple different use cases, right? I think you're all familiar with KSQL. That's a streaming Kafka job you can run. So what you would do is you'd basically have two topics. You would run a streaming join between them, and the output of your query you would write to another topic, which should be enriched or enhanced, and then Druid would read from that topic and enhance that data. So that's generally speaking a kind of industry best practice when it comes to analyzing Kafka data. But I've seen a lot of other use cases as well. Apache Beam. I think a lot of people have used that before. Spark jobs are extremely popular in the industry. Using Python Spark and PyDruid, you could actually query Druid directly, join the data in Spark, and then have Spark jobs write directly into Druid. Apache Flink, a lot of people have done streaming joins of Apache Flink, so you can enrich a topic, and then Druid can pick it up from the topic and read it from there. You can also write to S3, and then Druid can read from the S3, but that kind of isn't the point of this talk. The point is to write a data pipeline. So the point of a streaming pipeline is to do streaming analytics on your data, write it to your destination topic, and then Druid can store it, then analyze it as you need it. So the capabilities you can do here is pretty flexible. You can also run Pulsar, by the way, if there's any Pulsar people here. You can run it against Apache Druid as well. Overstock is a huge fan of Pulsar with Druid together. I know those guys are pretty cool. So the next thing I'm going to do is just talk about contributing to the open source community of Apache Druid. There's about 150 companies here on the Apache Druid website. I'm talking Splunk, Nielsen, Expedia, Swisscom, Zscaler, WalkMe, Dream11, Game Analytics, Outbrain, Twitter, and much, much more. If you're currently using Druid, send an email to community@imply.io. We're very happy to showcase you in the open source community. We have open source roadshows going all the time. Kind of our goal behind our venture-backed firm was to really build the open source project behind this technology. So this is kind of one of our big initiatives. Next is, we have a Druid forum. So go to the Druid forum, ask your questions, tag away, create some content, explore some information. And that's kind of what the Druid project site is. So if you go to the Apache Druid website, there's a lot of fantastic tutorials on how to get started on Druid, how to ingest Kafka data, how to connect to a Kerberos, how to read from example data sets, how to deploy it in production. We have K8s examples of Druid. So if you want to run like on Kubernetes, be my guest, that is fully available to you. And we have a lot of pull requests. This is a very vibrant and active open source community, and we'd love to see contributions from people like yourselves. This is an open source conference. Let's all embrace the future, which is distributed analytics. And finally, we're looking for people to just talk about how they're using Druid, how they're interested in using Druid, how they're interested in taking it up. And last but not least, we offer free public training, completely free. Like a 3-5 day crazy course learning Druid. You don't have to pay anything. It's on learn.druid.io. See that link at the bottom? Put it in your phones. Start learning Druid. So this is kind of my talk. Do you want to see a quick demo of Druid? Do you guys want a Q&A? Show of hands if you want a demo. Okay, cool. So, demo first, then Q&A. All right? Okay. So, basically, whenever you connect to Druid, you have what's called an ingestion task. This is where you define it. This is connecting to a Kafka topic. So this is just streaming data. As you can see, we have clicks and sessions. So you have a sessionized streaming join of data. And this is a UI as well. So what you do is once you get in there, you can click it, and you start defining your columns, what they look at, and you can start filtering them. I've written some pretty crazy JQ filters on data before. It's pretty fun. We've introduced a new feature called nested columns. We also have something called a multi-stage query engine. So if you don't need sub-second queries, you can join data, pull data straight from the cloud, join it in aggregate, put it in a Druid, and then query it. So there's a lot of interesting things. So this is Kafka data. It's all columnar. You can transform it if you like, define data, filter data. Here's where you configure the schema, so you give it different data types. Oh, sorry. I was scrolling too much there. You can partition the data. So the interesting thing is you can segment in different granularity. Like you can store it in segments of 1 hour, 1 day, 1 month, 1 year. You can optimize your data to just query it down to like the hour, and that means all of your data will roll up to an hour. So you can really optimize a certain amount of rollups. Like I did one POC of a customer where we needed to roll up 99% of their data. And then finally, this is your ingestion spec. This is kind of what it looks like. So when you finish doing Druid, okay, so did I put a link? Druid tutorial, quick start. So here's kind of the quick start. There's a lot of different tutorials, loading files natively, Kafka, Hadoop, querying data, rollup, configuring the retention, updating existing data, compaction, deleting data, learn.druid.org. If you want to see what we do at Imply, is we actually build UIs on top of Druid. So basically, if you just want to slice and dice your information and just explore it, this is kind of what we do for various customers. And that's kind of our contribution to Druid, and why we built it was to power very fast analytics. Like this is gigabytes of data just coming in all the time. So yeah, we're about halfway through this talk. Let's have a conversation. Questions? Yes, you've been waiting patiently.
So Druid's meant to be for insert-heavy update light, correct?
Yeah. So it depends on what you mean by updating. So when a lot of customers mean updating, they usually mean like updating an actual row. The way you would do updates in something like Druid or Apache Pinot is you give it the latest record on time, and then when you query, you basically aggregate per minute, per hour, per second, and the latest value will then be updated. So that's kind of how you update on an analytics engine. You just insert a new value for that particular timestamp, and it's going to roll up to that value. It's not an intuitive update, but basically it's a roll up to time, which gives you the most up-to-date value. So it's an aggregation, if that makes sense.
Okay. Is there an inflection point at which there's too many updates and Druid is not the right tool to go?
I think it depends on how big of an update you're talking about. Like if you're talking, I can't really think of anything. Because if you're trying to roll up to a particular segment of time, and if you segment your time for like an hour and you're always adding data to that 1 hour, that's okay. But if you're aggregating on like a second segment, then you shouldn't be really having segments in second or minutes. It should be like 1 hour segments. So basically the trade-off I would answer for you is if you're updating on something like a day or an hour, that's fine. If you're saying a minute, that's bad. And especially if it's like petabytes of data, that's when you like start hitting into issues. So, or you can't actually, I don't know if you could do segments on a second basis, but that's definitely in the theoretical end. But I could talk to some other companies doing it and see what you think.
Gotcha. Yeah, we run a fraud detection platform, and sometimes our clients will come in with these updates much later.
Yeah, that's fine.
Okay.
That's actually the use case that I love about Druid, because when I was doing clickstream analysis in Kafka, the problem was late arriving data. You know, you have 5-minute window analytics, and then if your data comes outside that window, then you have to write the business decision to handle that. And Kafka, Druid's perfectly designed for that use case, because at the end of the day, if that data comes a month later, I don't really care, because it's still that same time segment, and it's going to go to that segment, that 1 hour segment from a month ago. So that's a perfect use case for Druid. Druid's designed exactly for that. Any other questions? Come on.
I have a lot, but I'll wait.
No, let's have a conversation. The whole point of this is to chat. Yeah, go. Yeah. Okay. Yeah. I mean, I've seen use cases where people have multiple time columns. I haven't made sense of it yet, but you know, yeah. Yeah.
In your query example, obviously the columns you're doing the where clause on, the throughput clause on, were very suitable for compression.
Mhm.
But what if you want to do that on something that's more unique, like the price value or something that's not easily looked up? Does the performance take a hit then?
So there are something called approximations, and to be honest and transparent with you, I haven't used approximations before in a POC of a customer yet. But in theory, you can give a certain amount of confidence on fast-moving data, whether you want to get a precise, perfect calculation to like, you know, the millionth percentile of accuracy, or if you just want like a 90th percentile or a 95th percentile. So depending upon how accurate you want the calculation to be without compressing your data, that is kind of the trade-off. I can't really speak to it because I haven't used it yet, but I'm happy to have a conversation further. You can speak to some of the engineers that work on percentiles and approximations.
Okay.
Yeah.
So the historical data gets written to SSD.
Mhm.
And is there, I guess, what's the speed difference between reading from the SSD versus something more recent in memory? Like this query, you know, farther back in time take a lot longer?
So basically the best way, I don't know if I quite understand your question, but I can show you on Druid itself kind of what's going on. So if I click on services, I can look at my cluster, I can see how much data is stored, and I need to go in front of it. So this is where all the data is stored, right? You have your data nodes, and then these are the middle managers. They actually run jobs, whether it's ingestion or queries or updates and deletes. Now on the broker side, which is where the queries are done, we can actually cache the queries in memory. That's kind of what I meant by infinitely scalable. So if you're running the same query every day at 5 p.m. for 1 million users, your broker node will cache that query across 100 broker nodes. So that's kind of that use case in particular that you're talking about, where the query will be in memory, therefore it will be returned without any compute cost whatsoever.
Okay.
Did I answer your question, or was that kind of a...
No, I guess the question so data from a year ago, right? It gets written to disk.
Yep.
So then when someone queries it, it has to be read from disk, right?
Yeah.
So I guess the question I was asking is, what's the comparison between when you're reading from disk versus when you're reading something in memory?
Yeah, disk will be a little slower. Truth be told, there's data tiers that you can configure in Druid. So there are two things you can do. One is query laning. So if you want that query to be faster, you can give it a priority in the laning of queries. That's not going to particularly make it faster for use case, but if you have a heavy use load, that's one way of prioritizing queries. The second is tiering. So when I did a POC with Fanatics, they had to query data for a week. They needed data for just a week, query that data in real time, predicting store sales, powering their superset dashboards. And then they want to store the data for a year. They don't really query it often, but they just want it there to basically analyze, slice and dice it, and explore the information. So that's one use case. In your particular use case, if you're querying data a year ago every day at a certain time, I'm sure it'll be cached. But it all comes down to how you configure it. So you can have a hot tier, a cold tier, a warm tier. It's all about how you configure the cluster for that particular use case, if that makes sense.
Yeah, I think I hear you.
Go ahead.
Do people ever do real-time transaction blocking through?
Transaction locking?
Transaction blocking, for the fraud use case, basically. Is it fast enough for that, reliable?
So Druid is not a transactional database, as far as I know. It's not, atomic and all that. It's just analytics. But you could use it to do analytics on transactions. I think, American Express does use Druid for fraud detection, as far as I know.
Okay, so they'll block a transaction in flight, and it's quick enough.
What was your question? Sorry.
A financial transaction. Can they block a financial transaction in flight using Druid?
So
Something else is, user streaming.
let me explain it as a data architecture, because you're asking the right question, but Druid won't block it. It will be a query.
Yeah. I guess, is it fast enough to service that query?
It is.
Okay.
It absolutely is. That's what Amex does. So basically what they do is they get all these financial transactions that come into Druid, and they're querying it, every second for different user profile accounts. And when the query hits and the logic gate hits, hey, this query returned a result that should trigger some kind of warning, an email, a Slack message, a ServiceNow alert comes out, and that triggers a whole chain of events that goes back to the transaction processing system and, notifies the customer, notifies the people team. So basically, to answer your question is yes, but it's not Druid itself. That's a system that's querying Druid. At the end of the day, Druid is a querying engine. So you need a tool that basically just queries Druid. Does that make sense? Think of it like Grafana. You can have Grafana run cron jobs or, yeah. Yeah, absolutely. Come on, more questions. No? Want some lively conversations here.
Do you have any performance benchmarks offhand? How well Druid does and pushing scale?
Yeah, we're actually working on a proof of technology using a certain benchmarking standard, and we're going to publish that within the next couple of weeks to a month or two. We can personally connect on that. I can set you up for a director of product engineering that's working on that benchmark criteria. Are you using Druid in production or evaluating it right now?
We're evaluating. We're having issues scaling.
With what are you comparing it to?
A few different things. I mean, it's also a product question, like do we want to support real-time transaction blocking? Or should we just go with something like Delta Lake, where we can still process at volume and do stuff historically for compliance and product application after the fact?
So there's a slide I always use. Just give me a second. That I ask all of our. Sorry. No. I mean, this is why I love this conference. If I could just find my mouse, so that would be great. Okay, there it is. Okay. Yeah, so whenever I talk to a customer, I always ask these 4 questions. Just 4 questions. Do you need interactive queries? Do you need sub-second OLAP queries? Do you need sub-second analytics? Do you need a point-and-click UI? Yes or no? You don't know, it's okay. Next is, do you need unlimited scale? Do you need high concurrency, petabytes of data, and need to ingest a lot of data? That's another thing you have to think about. Do you need to combine real-time and historical data? Do you need to look at a clickstream of Kafka data and then maybe also, read the same Kafka data from a year ago? Or maybe you need to correlate it with your S3 data, your Hadoop data, your Spark data. And finally, do you need something that's cost efficient? Doing something like this on a cloud data warehouse lake is incredibly expensive. Cloud data warehouses are not designed for concurrency. They're not designed for 1,000 users. They're designed like, I don't want to name other systems, but they're not designed for concurrency. That's kind of like the broad implication. But in your use case, just ask yourself these 4 questions. And if these 4 questions make sense for you, then Druid is a good fit. And if not, then maybe something that's a little slower but a little cheaper might work. That's things to think about. Any other questions? Yeah.
Are there any rules of thumb about how I'm imagining if you had a column like email address that has a really high cardinality.
Yeah.
Rules of thumb about what's too big, what's too high cardinality? Because city, sure you have 5,000 cities in the U.S., but phone numbers, that's insane. Is there best practices somewhere?
Yeah, that's a good question. So when I was doing things with Kafka, whenever you're doing key value and bucketing of your data, a classic pigeonhole problem, right? You don't want to put all of your data in one bucket. You want it to be kind of evenly distributed. So the more evenly distributed the data, the more generally heterogeneous your data consistency is. But Druid's kind of more flexible in that first it's partitioned by time. So, as long as your data is kind of roughly, the truth is I don't know. It's something I got to learn to be honest with you. But that's a very good question.
Okay, but I see your point about indexing by time.
Yeah, so there's secondary indexes really in Druid. So first it's time, primary index. Then depending on how you design the columns, the first column is indexed first, second column is indexed third, fourth column is indexed fourth. So it's the order of the columns that really affects the priority of the indexing. So if that column is most important to you, I would move it to the left, right next to time. That's kind of the simplest way to do best practice with Druid.
Gotcha.
Yeah.
How operationally intensive is it to try
Yeah, that's a good question. You could hire an SRE that might know Druid. There's multiple things you have to manage, right? You have your query nodes, you have your data nodes, you have your middle managers. You need someone to. We provide open source Helm charts, so it's easy to get up and running, and there is an open source community. I am with Imply. We do offer managed services for this technology. We have professional services. We have software which makes it easy, serverless, all that good stuff. So I would say the bottom line is operating it shouldn't be a limitation for you. It's just, do you have a use case that requires sub-second performance on massive amounts of data with a massive amount of users hitting a dashboard? If you answer yes to those three questions, then you need something like Druid.
And sorry, what would you consider the baseline for massive, for data volume and users? Like, what would be the minimum?
Yeah, that's a good question. So if you're looking at, have you used something like Postgres or Redshift before, these different systems?
Postgres, for sure. Yeah,
so with Postgres, I'm sure you've all run into the issue where you've tried to query a million columns to another million columns, right? I ran into this issue 6 years ago where, we downloaded this data set. It was just 20 gigs, not a huge data set. But they wanted to query, like, I think 1 million rows against 100 million rows. And I ran this query. It never finished. I mean, it never finished. And my roommate at the time was like, why don't we just try Redshift? And I'm like, what's Redshift? I'm like, I don't know. So we partitioned the time on Redshift. And we did get the query done in like 5 minutes instead of all week, which is pretty cool. So like, MySQL to Redshift is an order of magnitude better because it's parallelable. At the time, MySQL was single-threaded, so there's no way that one thread could go through 1 million rows on this side, 100 million on the other. So something like, Cassandra, Redshift, Druid, they all kind of horizontally scale the compute requirements, and it gives you more parallel processing of executing of your data. Generally speaking, you need Druid when you need less than a second, like very fast, like 50 millisecond query time. Like if you're doing financial analytics, for instance, that's a very, very good use case for Druid. If you're doing network analytics, Spark jobs, right? Spark is very powerful. You can do like what's called a fact-to-fact join on Spark. Like you can join 1 billion events with 1 billion rows and put it all together, but that query is going to take you, a few minutes, a few hours. It's a batch job, basically. So Druid is designed for real-time kind of queries. So different technologies service different use cases, and that's kind of something you need to explore. So the 3 things you need to remember, right? Massive concurrency of users, massive amounts of data, so usually gigabytes is a good place to start. If you're loading in like a couple gigs a day, that's a very good place to start, right? Gigabytes a day of ingesting, whether it's real-time or batch, that's where Druid comes in. And then, if you need to query that data in less than a second. Did I kind of address your question or open up to a broader conversation?
Yeah, I think that's it.
Okay, cool. Yes?
Does Druid support window functions?
We are working on that.
Okay.
We are working on that. That is, so that's kind of the thing. Druid is not ANSI SQL yet, so that's something we're working on. So because we have a new SQL origin, we're not a fully ANSI SQL database, so some of those functions, like a window function, for instance, isn't quite there yet, but we do kind of have it. Eric Cheddar is working on the workflow around it. It's coming out in the open source version in a couple of months, I think a month or two, but don't quote me on this, although this thing is filmed, so.
And does it support array aggregation?
I don't know. What are array aggregations?
In all like the latest and greatest SQL languages, you can like operate on arrays in like your columnar database structure.
Okay.
To do like similar operations.
I haven't tried that, to be honest with you. But we can look that up. Let me see. Do I have?
Yeah, sometimes.
Well, I mean, help me out, because Postgres say has array ag, which is
Right, that's kind of what I'm
which is
thinking.
going to take your n rows and turn it into a single row with an array. Is that what you're asking?
Essentially, yeah. And then if your data's already in an array, like, and you wanted to do like a
So, yeah.
Yeah, I just want, yeah. Okay, fair.
Yeah, so to be transparent and honest with you, I come from a streaming background. So to me, I do like KSQL joins, streaming joins. So all these different models of SQL is a little different for me. But, you know, there's different ways of aggregating information. We also have JSON type SQLing. So the best way to do it is just to explore Druid, you know, try it out. Try our SaaS, you know, try Polaris, you know, set up a 30-day trial in the cloud, put in your data, see what you can do, see what you can't do, and that's kind of the best way to understand what it can and can't do. Any more questions? We got 10 more minutes. Nope? Come on. Yeah. Okay.
And I'm just looking at this, how Apache Druid plan with Snowflake, and then I saw this Druid versus Snowflake.
Mm-hmm.
So this is just for analytics.
Yeah, so that's interesting. So I can give you the pros and cons of each system. Snowflake is, generally speaking, it's cheap because they just store all their data in S3, and you're just querying the data off of S3. So you're not like, you know, storing that data locally on disk, on like some SSD drive and a lot of memory. Generally speaking, for that reason, you could consider it to be cheaper. Now, it's cheaper when you have one user. It starts very cheap, but as you have 10 users, it goes here. As you have 100 users, you go here. That million users, forget it. So Snowflake doesn't really scale for that concurrency use case. So that's something you should think about. So Druid is designed for concurrency. Yes, it's a little more expensive initially because you have to pay for much more underlying hardware. But when it comes to concurrency and queries of your data, it should be cheaper in that regard. So sub-second performance is also kind of key. You know, Druid's, Snowflake, these are all cloud data warehouses. So to get them that fast, they have special pricing for that. And concurrency is not something that they are really architected for. And as a consequence, they're more expensive for concurrency kind of use cases.
So what, what Druid is provide for like local unit testing? Do you have like that Docker container and quickly like launch and then like
I couldn't hear you. What are you asking?
Okay, so like any like Docker or the Docker Compose that Druid provides for easier local testing?
Yeah, we have a Helm chart. Yeah, we have a Helm chart. So
that's the Minikube.
Minikube, Kubernetes, you know, deployed on AWS, deployed on Azure. I'm very good at Kubernetes, so I can get you up and running in like 5 minutes if you want. We can talk about that. But yeah, like Helm charts is easy. Docker Compose, not exactly. It's just do Minikube. Minikube's better anyway. The world's moving to Kubernetes. That's the new fact. But yeah, kind of like if you're looking at a cloud data warehouse, just ask yourself one question. Do I want to have this powering a dashboard? If you want to have it powering a dashboard that all of your employees are going to use, then a cloud data warehouse is not a good database to power that kind of use case. You would want to use Druid. But if you have like a data science team of like 5 people that need to run, you know, some queries here and there, and on a lot of data like Spark jobs, that's where a cloud data warehouse makes a lot of sense, or a Delta Lake. So that's kind of the use case where those data really make the most sense. Yeah. Questions? No more questions? Should we conclude? You look like you have a question. What's your question?
No, I don't have a question.
Oh, okay.
Put up a POC next week, probably.
Okay. Yeah, let's talk.
Actually, I don't have a question, but I was impressed on that website. You have a very good example of downloading it, and within 5 minutes, I was able to hit JSON, 30 gigabytes, go through the different steps and load something quick. Impressively set up.
Cool. Thank you, Bassam. No, he's not. Thank you. Bassam and I worked together for 3 years at Instacluster. It's a very good vendor for open source. You can go see them downstairs. Yeah. Do you have a question, Mark? Okay, you're here bright and early. All right. If there's no more questions, thank you. What's your name? Peter. Peter, let's chat.